All right, so I hope that you guys were already there. So let me know if you guys are really there on your screen. So how about giving me a thumbs up just to see that you are already here? Okay, I'm seeing 5 thumbs up. Okay, 6. Okay, so it seems that most of you are already here. Okay, so let us now continue our discussion. So with this one you're doing, so again, I gave this one as your 6th quiz. So right goes the print all of the odd numbers from 1 to 50 using the do-while loop structure. Okay, so I should see a do-while loop structure with your 6th quiz. Okay, so are we clear regarding with your uh, quiz number 6?
Yes, sir.
Okay. How about the others? You guys have a question or clarification regarding with the quiz number 6? So I'm pretty sure that, just by learning this one, exercise number 1 and 2 and 3, you will be able to answer this one already in just 5 minutes, 5 to 10 minutes maybe. All right, so that's it for the 6th quiz or quiz number 6. All right, so let's continue now with the exercise number 4. So with the exercise number 4, it says here, write codes that compute the squares and cubes of the integers from 1 to 10 with the following output. So note, use list box property items to have those titles or headers, numbers, square, and then cube. Okay, and then we have here the sample output. Okay, we have the numbers 1 to 10, and then their equivalent results in squared and in cube. All right, and here's the solution using the do loop structure. Okay, and we have another solution here using the while structure. So again, both of them will give you the same result. It's just that the uh, syntaxes were in the differ with each other. So let me show to you guys the sample output of this one. So that one is exercise number 4, right? Okay, so in here, I have used the do loop until. So I have declared 3 variables in total, the number, SQ, and then the cube. While in here, you can actually combine this one into one line only, number, SQ, and then cube. Oops, sorry. Okay, so we cannot do that one since equating all of them in one, if I will have that one in one line only. So we only want to equate the one variable, which is the number, equal to 1, since this is our starting number. Okay, and then the others, the SQ and cube, has a different formula for it to solve the squared and then the cube. Okay, so in here we have the do, okay, and then the SQ, wherein how do you solve the SQ squared? So just simply square the number, which is this one, number squared or raised to. And how about the cube? So since we're talking about cube, so just raise that 1 to 3. Okay, so in that case, you are now cubing that certain number. Okay, and then we're going to display, okay, those results on our list box 1, that items that add. So this is the first variable, okay, which is initially is 1. Okay, and then it will loop until a number is equal to 11. Again, this will stop looping once this one became true. So as you guys can see, it will not reach 11 anymore since once it reach 11, so 11 is equal to 11, which is already true, so it will not initiate that one anymore. So that is why it will stop at exactly 10. Okay, so initial value is 1, and then it's incrementing by 1, and then it will stop at exactly 10. So that is why we have 1 to 10 as our number. Okay, and then here's where we are displaying the result of that numbers. Okay, and then we have a function right here, and bb tab end. So end is just basically concatenation when it comes to strings. So we are just combining this variable to this variable, but of course we have to put space or a tab. So this bb tab is actually the same with the tab that we are doing in Microsoft Word. So if you guys can see this one, if I click tab, okay, it will give me maybe 5 spaces, 5 blank spaces. So that one is the same with our bb tab function here in bb. Okay, it's just that we have a word bb here that's indicated that's a bb function, and then the word tab for the tab function, a bb tab, and then another concatenation here for the squared variable. Okay, and then another bb tab for 5 spaces for the cube. Okay, so in that case, you will have 5 spaces, okay, between those two results. So number, before going to square, it will, you know, leave as 5 space. The same with the square to cube, it will leave as 5 spaces. Because if you're not going to put a bb tab in there, let's say number and square, okay, just wait a second. So there you go. So as you can see, we don't have a space anymore. So 1, 2, 3, 4, 5, 7, 8, 9, 10 is now beside the 1, 4, 9, 16, 25, 26, 49, and so on and so forth. Okay. So to avoid that one, we should include here a bb tab function. Okay. We have this result. All right. So were you guys able to follow this a little?
Just a little, sir.
Okay, it's rather okay. So it's better than not able to understand anything. Okay, 20% is already a very big thing. Okay, it's already a progress. So all you need to do, just to reach the 50%, 70% of understanding is to do this one on your own. Okay, that's why I keep on mentioning that the best teacher is the experience. Okay, so we have the saying that you will not be able to appreciate it unless you will experience it by yourself. All right, so again, all of the codes are already in here, and then the things that you will be needing is already mentioned that you're going to use list box. And one more thing, I forgot to show you guys the properties. So under the list box, so by default, this one is blank. Okay, you will not see anything. Well, you will see list box one as a name in here, but by default, once you play that one, you will not see anything. But in here, you're already seeing the number squared and then cubed as the title or header, because I have put that one on the collection. So just look for items on the properties of the list box, and then go to the collection. Okay, just click the triple dot, and then it will show you this string collection editor. So in here, you can put anything that you can put inside of that list box. So I have only put 3 words or the titles of this one, like number, square, and I already click OK. So in that case, I already have my titles or my headers. Okay. So yeah, that's it for the exercise number 4. So again, the one that we have used is the do loop until. Okay. And the other one is using while. So you can use any of those two. Those two will give you the same answer or result. It's just that they are differs when it comes to syntax. Okay, so I'll not show this one anymore since it will give you the same answer. Next one right here is your turn. Let's say write codes that print the degrees Celsius from 5 to 45. Step 5, read your equivalent degrees Fahrenheit as follows. So we have here a sample output, a result of this given problem. So we have the Celsius starting from 5 up to 45. And then we have here the equivalent Fahrenheit of those Celsius. So 41 to 5, 50 to 10, and so on and so forth up to 113. Okay, so it says here use list box. And so no solution anyway. So let me show to you guys the result of that one. Return degrees conversion. I guess this one. Degrees sine tangent. Okay, not this one. Okay, let me just find that exercise. I guess it's this one. All right, so I guess I wasn't able to do that one yet. Okay, so let's just create a new one. And I'll name that one your turn. Celsius to Fahrenheit. Right. So mention there that we have to use this box. List box and a button. Let me just change the font size of those two. There you go. I guess that's not enough. Okay, and then we'll put here the headers, the Celsius, and I'll just click tab so I can have 5 spaces. And Fahrenheit. There you go. Double click this one and then put it as a recording section. So in here, we have initially is 5 and then step by 5. We have to declare two variables, the Celsius and then the Fahrenheit single. So why single? Because we want to let's say our variables to show a decimal value. Okay, and what's next? L is equal to 5. And then I'll use do while. So you can use any structure that you want, but in my case, I'll use do while. Wherein do while x is lesser than or equal to 45. So 5 to 45. And then for us to be able to compute the Fahrenheit, so I forget how to convert Celsius to Fahrenheit. So let's search for the formula of that one. So we have here 1.8 or 9 divided by 5 and then add by 32. So you have to multiply that by Celsius times 9. Oops. 9 divided by 5 and plus 32. Add 32. There you go. So we already have the Fahrenheit. And for the Celsius, so it's incrementing by 5. And we'll show the result on the list box. List box 1. Okay, so the first one is Celsius. And then of course, we have to put a space here. So we're going to use the VB tab function, VB tab, and then followed by the Fahrenheit. So I'll show the result first before I'll increment it by 5. There you go. So let's see. 5 to 45 up to 113. There you go. So in here, we are seeing a decimal here. We have 2 decimals. So in that case, just convert this one into format. It's whatever is a computed value be formatted by fix. So this fix function right here came from the module 7, if you guys were able to see that one. So fix value is, it will give us, or it will only get, or it will only show 2 decimals, okay, of this computation. So, oops, it's not showing as anything. All right, so I think this is the wrong place to put a format. So I'll choose Fahrenheit. So how about here? Format, so whatever is the result of that Fahrenheit will be formatted into a fixed value. So let's see. So there you go. We now have 0.00 in here. So let me just adjust this one so we can cover the 45 value. So there you go. So we have 5, 45, and then 41 to 113, which is now the same with this one. Okay. So again, I've just simply used the formula, okay, of the conversion on how to convert the Celsius to Fahrenheit. So we have this formula right here. Okay. And it's incrementing by 5. Okay. And then showing the results on the list box 1 that items that add, wherein the first one is Celsius, so 5 up to 45, and then the Fahrenheit, wherein we formatted that one into fixed, so it will only get the first 2 decimals. All right. So were you guys able to follow? Okay. So yes, sir, coming from Mr. Kit Jasper, so very good. If you were truly able to understand. And to the others who are still confused, again, I highly suggest that you guys do this one on your own Visual Studio for you to be able to appreciate what is really happening on this code and to your program. Anyway, that's it for the your turn secret, the Celsius to Fahrenheit. And in here, we have another exercise, which is exercise number 5. So the bank charges 12% simple interest on the amount per annum. Okay, annum is yearly. Okay, so write a VB program that allows the user to input for the amount loaned and the number of years to pay, and compute and display the lump sum amount for each year. So in here, we have a sample output. So we have here amount loan, which is 30,500, and then the borrower chose to pay this one for 7 years. So in total, okay, he has to pay 56,120 at exactly 7 years. Okay, so this is the lump sum amount, okay, for exactly 7 years. So if he chose the, let's say, 2 years only, then it will only have him a very small interest, 37,000, from 30,000 to 37,000. However, course, choosing a 7 years payment or method will give you a very, very big amount of interest. Okay. So we have here the formula for the amount. So P is the amount to loan, and then 1 plus R. R here is the interest rate, okay, which is 12%. Okay, so that's yearly, 12%, 12%. So imagine this one. The company have gained 12 times 7, 714, 7, 104%. Okay. Yeah, 104. Correct. 104% of interest. Is it really 104? Let me check. So 7 times 12. 84 only. 84 percent of interest from the original amount that the borrower has borrowed. Okay. And then P is, of course, the number of years. And here's the given code for this one. So I have already created that one. So let me show to you guys the result. Exercise number 5. Exercise number 5. But it seems that I haven't created this one yet. Exercise number 5. Yeah, I guess not yet. Anyway, so let's just create a new one. So if you guys have a question, so feel free to ask me. In this one, exercise number 5. And we need 2 text box, 2 labels, 1 button, and then 1 list box. So we need label, text box, a button, and a list box. I'll just change the font size of those into 30. There you go. I just make this one bigger. So right here is the amount to loan, and then the second one is the number of years to pay. This one is amount to loan. Oops, we don't need that one. And then number of years to pay. Number of years to pay. And a button. Or compute rather. Anyway, I'll just put here calculate. Okay, and then this is the one that we're going to program. But before that, we have to include this one right here, the year, and then the month per year. I know. So it's already included here. Okay, so let me explain that one later on. So supposedly I'll put here the names for the year and then amount per year. But you can also do the titles or the headings on the code itself. Okay, so you can do that one without going to the collection and then edit whatever is the text inside of this list box. All right, so let's see if it doesn't have an error. So we have an error here because this one is list box 1. There you go. Okay, so in here we have declared 3 variables as integer: the amount, b, and then the time, okay, or the years or number of years that you wanted to pay it. And then we have declared another variable, which is a constant, the 12%. So this is the interest rate, okay, which is letter R. And then we have here the text box 1 as our input that will be passed on to our P, okay, as the amount to loan. Okay, that's our text box 1, the text. And then we have here the list box 1 that items that add were in. This is actually the headers, okay, or the titles that you'll see here later on, year and then the amount per year. Okay, it's one right here. And of course, we have to, add 5 spaces using VB tab function. And then we have here the initial time, which is 1 year. Okay, so this is actually the lowest year, okay, that you can put there. You cannot put 0.5 because we're only talking about years. And then we have used this structure to while. Okay, so while p is less than or equal to text box to the text, then it will keep on looping. Okay, so if you put there, let's say 5, then it will just keep on incrementing by 1. Okay, and then at the same time it is showing, okay, the computed lump sum amount every year. Okay, so if it loops 5 times, then it will show us the uh, lump sum amount in 5 years. Okay, so the first one is the time, and then the second one is the amount. Okay, and here's the formula for the computed lump sum amount. So P is the borrowed money times the 1 plus the interest, which is 0.12 times time. So whatever is your input there will be multiplied right here. So if I will show this one, say 35,000 in 5 years. So this is the first 5 years, and then this is the amount per year that I'll be paying. So in 5 years, I have a lump sum amount that I have already paid, for 56,000. So it's quite big when it comes to interest, 0.0 or 12%. Okay. So in here, you guys are seeing a 0.00, wherein again, just format this one to fix so that we'll only get the first 2 decimals. So in that case, let's see, 30,500. 30,500 in 7 years, then you will have the same result. Okay, actually, there's another one wherein we have PHP right here. Yeah, peso sign. Or we can also do that one. So right here we have PHP. Amount plus fixed value. 30,500 seller. Oops. I guess we're having an error. PHP and VB tab. Forget that. And so we have to concatenate those two. 30,500 and in 7 years. Oops. It's not only showing F. PHP and amount. Alright, so I guess I have to put this one outside and VB tab. Go. Oops. Forgot to remove the end right here. 7 years. So there you go. We now have 7 years, and then the PHP word or string, and then the value, and then the fixed value or the 2 decimals. So were you guys able to follow regarding with exercise number 5?
Yes, sir.
All right. So again, sir, paano pag dollars? So if you want dollars, okay, then just change this one into dollars. Okay, then you will now have a dollar sign in 3 years. There you go. Okay, so yeah, we have a dollar sign in our keyboard, so you can use this one. All right, so that's it for the exercise number 5. Well, anyway, you can just again simply copy the code, and just if there's an error, then just troubleshoot that one and look for the errors and solve it. And then you can run it and then try to check if you have the same result. Anyway, for the exercise number 6, I'm sure that I have already created this one. So let's see. Exercise number 6. There you go. Oops. Okay. So in here, a bank offers a car loan at a rate of 15% compounded monthly. Write a program allowing the user to input for the loan amount of the car and the period of years to pay. Compute and display the monthly payments to amortize the loan and determine the total amount at the end of the period. So for the interest, so we have 15% by default. So just divide it by 12 since the computation is monthly. Okay, so you have to divide it by 12. Then that's the interest every month. Okay, that you will multiply for the total contribution or annuity amount that you have already paid. So in here we have the formula for you to be able to get the total contribution. Okay, and what else? Yeah. So let's see what else more we have here in the code. So in here we have declared P and then int and then tot amount and then amort as single. So why single? Because we wanted those variables to give us the result of, let's say, decimal, okay, or yeah, as long as it has a decimal, then it will be able to show that since we have declared that in single. And then the other two, which is term and then m, is declared as integer since will not be needing decimal on that one. So for the text box 1, okay, that is actually our amount to loan, and then it will be passed on the variable p. And then for the term, okay, which is the interest actually, no, not interest, sorry. Term is actually the years to pay. We were in, if you will put here 1 year, so it will be divided by, multiplied by 12, okay, since the computation will be monthly. So if you put here 2 years, then it will be multiplied by 12, so it will become 24. 24 months in total. And then the interest, of course, 0.15, okay, the one that is being mentioned here, divided by 12, since the computation is again every month. And we have here the headers. So these are just the headers. Month, annuity, and then the total contribution, which is this one, month, annuity, and then total contribution. And the amortization or computation is this one. So there is actually a correction regarding with this one. So if you're going to check this one, so we have the P is equal to A, wherein A right here, okay, is the amount to loan, okay, which is P. Yeah, this is correct. However, the next one right here is the int times 1 plus int raised to term, wherein the one that we have in numerator, okay, is the one that we have in denominator. So you have to interchange, or you have to interchange the numerator to denominator, and then yeah, vice versa, the denominator to numerator. Okay, so the one that we have in here is the denominator, and then the one that we have on the denominator is actually the numerator. So 1 plus interest raised to n, which is 1 plus interest raised to term minus 1. Oops, minus 1. Right? So that is the only correction regarding with this one. Because before I have interchanged those two wherein it will give us a different answer. Anyway, so yeah, that's the correction for the formula. And then we'll start with month is equal to 1, which is this one, of course. And then the tot amount is equal to tot amount is plus amort will be this total contribution. So basically, we'll just add whatever is your last value. So initially we have 18,000. Of course, it will be put in there. And then in here, you have already contributed 18,000 plus 80,000 will give you 36,000, okay, which is this one, right? And then for the list box ones, that items that add. So this is now where we are showing the results. So M is the month from 1 to 12. So if you have 1 year, just multiplied by 12, then it will give you 12